Today, your job is to make 4 LOL diagrams for problems which include energy and also work, perhaps. And I'm actually going to do problem 1B for you today. You're not going to be able to draw on this diagram, on this picture, I don't think. So I'm going to make a drawing and put it in this box here. Also, you don't have to draw this part because I know it's in the picture already, so that's fine. But you're going to have to fill out the rest of it here and make sure that gets in the box. So when we look at this problem, we have to read it very carefully before we start. It says repeat problem 1A for a frictionless system. If there's a frictionless system, there's going to be no thermal energy created. And it also says that the system includes the cart, the earth, and the track, but the cart does not include the spring. So this spring right now actually does hold some energy, because that spring is going to push the cart, and then the cart's going to go around the loop and it's going to go that way. But that spring energy is not in the system, so we're going to have to find another way to account for that. In fact, that spring is going to do some work on the cart, and that's how the energy is going to get in the cart. So that spring is going to kind of bounce against the car is going to get pushed, and so the car is going to get some kinetic energy somewhere down here, but it doesn't have any kinetic energy quite yet. At least we can think it doesn't have any kinetic energy quite yet. It does have kinetic energy at the top, though, because you can see the little whooshies behind the car. So we know that it's still going at the top. So it's going to have some kinetic energy at the top. All right. So I'm going to go ahead and go into drawing and go ahead and start to make this drawing. So I'm going to go to Insert. I'm going to go to Drawing. I'm going to go to New. And now I'm going to go ahead and scribble here. I'm going to make my LOL diagram. That's a really horrible L or O in there, but that's okay. I'm going to leave it. I think I can draw in there. All right. And remember that energy goes on the side of these. Trying to figure out how much energy of each sort there is in them. And the first thing we have to do, because I'm not making you make that drawing again, it'll be there on the page when you insert this. So we need to decide what is the system. And the system does not include the spring in this drawing. So it must include the car. It must include the earth. That's how it's going to have some, gravitational potential energy. So it contains the car and the earth and maybe the track also, although there's no friction on the track, remember, so the track's really not going to have much effect here. All right, so let's think about how much energy there are in the car, the earth, and the track at the start. Well, if you think about it, the cart is not moving at the start, and it's not up on a hill. So it has no kinetic energy, and it has no gravitational potential energy, and really it has no thermal energy either. It's the same temperature as the room, so we don't have to say that it's hot. All right, so it has no energy at the start. Okay, so but what does happen at the start? Well, the spring does some work on the car. All right, and so I'm going to draw an arrow going into the system, because the spring is adding energy into the system. So this is an arrow that I'm drawing here. Energy is going into the system, or I shouldn't say energy, I should say working is going into the system. And how much of that is going in? Well, I'm going to say that 4 bars worth of energy is going into the system. So there's my 4 bars. When I say 4 bars, 1, 2, 3, 4 bars are going into the system. All right, that was not in the system at the start, it was in the spring. And now going over here, well, what energy ends up in the car? I'm going to just draw these lines here, and then I'm going to come back in a second video and I'm going to show you what energy goes into that car.